welcome to the latest episode of Last Week in AI, where you can hear us chat about what's going on with AI. I hope you enjoyed that AI-generated intro song, which I now use as the intro for every episode, always a new one. And now you unfortunately have to listen to our voices instead of that, but hopefully you are up for that. As usual, in this episode, we will summarize and discuss some of last week's most interesting AI news. And if you want even more AI news in your email inbox, you can go to lastweekin.ai for articles we will not cover in this episode. I am one of your hosts, Andrei Kurenkov. For some background, I finished a PhD where I did study AI at Stanford last year, and I now work at a generative AI startup.
And I'm your other host, Jeremy Harris. I'm one of the co-founders of Gladstone AI, this AI national security company. And this is one of those weeks. I think so. We're recording this on a Sunday. Normally we do it on a Friday, hence the last week in AI. We've got a couple extra days under our belt, and it's like the worst of all possible weeks for that because there's so much stuff. So we're gonna have to power through an awful lot of this, but. What a busy, insane, crazy week. And I just got back from a trip too. So it's like I did all my research on the flight on the way back. And anyway, so I'm a bit groggy. So I'll be even less coherent than usual. So enjoy that, everybody who's listening.
Yeah, and it's one of those weeks where the news is not dominated by OpenAI or Google or Microsoft so much.
Yes.
So we're going to get a little bit more variety than we've seen. Before we do dive into news, as usual, I want to acknowledge some comments and reviews we got. Some really good comments coming in on YouTube now, which I always like to take a look at.
They do always say the YouTube comment section is the highest quality source of... It's actually really good in our case. That's the funny thing.
Yeah, I think there's some really good stuff, there's some less good stuff, but in our case, we got some really good stuff. We got one comment that was very detailed and basically gave a feedback that, love a podcast, but at the same time, it does feel like every single China-related story we have kind of winds up commenting on geopolitics a little bit, and
it's kind of the nature of Chinese AI these days. But
I think it's true. We do want to cover that aspect of it, but maybe when we have research papers, we will try not to always mention it, while we will cover it in many respects.
I think this is a reflection of just sort of my work and where I tend to focus the most. I think it's a good comment and something that I'll absolutely update on. But I think it's just that you get in that mindset, and that's how you see the world. So. Anyway, I appreciate that comment. I think that's in particular directed at me, if I have that right. So I especially appreciate that. We'll take that to heart and give you less geopolitics with your side of Chinese AI research. But again, when it's relevant, we will of course be discussing it. So.
That's right. And we did get a bunch of new reviews on Apple Podcasts, which is always fun to see. Some comments about maybe touching on AI products and how models are playing into it. We try and cover that in the tools and apps section mostly. And there's so much going on that we usually don't get to a lot of these things. But I do keep an eye on it for things that people are kind of hyped about it. There was one review that was a 3 stars one and commented on the bias against mothers of 4. Apparently, Jeremy, you mentioned that at some point, which I don't remember.
I don't recall this, but let the record show that I love mothers, and I specifically love mothers of 4. I have a mother. First of all. And so I'm actually very strongly biased in favor of them. Mothers of 4 in particular, I'm a big fan. Mothers of 3, yeah, I'm okay with mothers of 3, but mothers of 4, man, big fan. I'm not sure what this is getting at, but
it's we try and riff a little bit, do some comedy. So if we do say anything mean, I think we are nice guys, or try to.
We try to, and look, I mean, the thing is, if you always have the option to have another child too, right? So if it is a mothers of 4 thing, I'm not trying to be. It's just if it's a mothers of 4 issue, you can get out of that category. That's an option, but you don't have to. I love mothers of 4, but I'm just saying this is not Andrei's position. This is just my position. I'm just expressing the option space here.
No bias against Marvel 4
No
on
bias.
this podcast. And I'll just mention one more. We had a couple that commented on not holding back on AI safety. So nice to see that. I guess most people don't mind it. One comment asked for an Audible version. And I did go ahead and add that, I think. So hopefully it is on there now for the listener who wanted it. And finally, Jeremy, I don't know if you remember last week you had a real struggle remembering a company that started with the letter V.
Oh, yes.
And someone on YouTube commented that it might have been Visionic's.
Okay, so I've got to call this out. I don't normally check YouTube videos all the time, but obviously I was traveling. I was like, wonder what the what the YouTube space is like these days. And I saw Alien Forensics. I saw you out there. I see you, and I appreciate you. It's not Visionic's. But the fact that you brought that up again made it so I couldn't get it out of my head. And it's Vicarious. I was thinking of Vicarious.
Yes.
Do you remember Vicarious? It used to be a thing, right? Yeah. So anyway, I guess if you go back to last week's episode, you look at the part where I'm just going nuts trying to think of this company's name. Just sub in Vicarious. Hopefully it'll make more sense. But thank you, Alien Forensics, for your wonderful YouTube comment, and to all the other YouTube commenters and other commenters out there. Super appreciate it.
Definitely. Well, enough of that. Let's get into the news, which is, of course, what people presumably come here for. So starting with tools and apps, we got first story is Odyssey building Hollywood-grade AI text-to-video models. So this is a new AI startup that was just announced last week. They have raised apparently $9 million in seed round funding led by Google Ventures, and they pitch themselves as this Hollywood-grade video with generative models that allow full control of the core layers of visual storytelling. So they say that these 4 models that they're creating will generate geometry, materials, lighting, and motion. And that's one of the challenges with AI-generated video. If you have just one model that generates the entire video, then you can't control some of these elements that you really want, like lighting and I suppose how things move, etc. So yeah, interesting to see this whole trend we've seen this entire year, text to video continuing to go at a rapid pace, more startups entering the fray, and I guess trying to find that product fit to make this actually useful as opposed to a very impressive demonstration of what AI can do.
Yeah, this is also one of those cases where it makes me think to a lot of the techniques from AI interpretability and AI alignment that are often discussed in the context of safety. But here, you can really see why they're important from a commercial standpoint too, right? Exerting finer control over AI systems so that you don't have to have separate purpose-built models because you need that level of fine-grained control. If we could build a monolithic model, like one model that handles all this stuff together, first of all, that's the ideal, right? Because you really want all this done, if you will, under one roof so that it can be done coherently. So all the physics, the lighting, all that stuff gets done by one model in a way that, kind of all the cross dependencies between those factors can be accounted for. This is going to be handled in a more ad hoc way here, but if you could have finer grained control over those monolithic models, then maybe you could actually productize them in these sorts of applications. That's anyway, sort of one stray thought there, but there's a video that they actually share, a GIF on the in the article showing this rhino, and it's not a video. They just sort of start with this still image, but they show you sort of what the rhino looks like under different lighting conditions. And the physics seems captured here in some really interesting ways. It's high resolution. It's very compelling. So looks interesting. We'll have to see what it looks like, obviously, once it's out and actually in users' hands.
Yeah, I think it's the case, like we might forget if you only care about AI, but computer graphics, special effects is a core element of movie making these days. And I think this is potentially taking some inspiration or some knowledge out of that, how people already integrate that into their workflows. Presumably, in the long run, these companies and professionals who take care of visual effects in movie making will integrate these tools into their workflows as opposed to just like AI takes care of it. Next up, Anthropic's Claude adds a prompt playground to quickly improve your AI apps. So yet another new feature coming out of Anthropic and Claude. This time, it is a feature that allows developers to generate, test, and evaluate prompts using the prompt engineering techniques we often cover to improve Claude's responses for specialized tasks. So there's an Anthropic console for developers, and there's now an evaluate tab, which is going to be this testing ground that can be used to evaluate your prompts. And then there's also this prompt generator that will have the ability to enter a short task description, and then will construct these longer, more detailed prompts. So there you go. I think making the use of Claude a little more, I guess, formal, and making it easier for people who leverage it to get the most out of it.
Yeah, it's also just a really interesting data set for Anthropic to be collecting, right? Because essentially what they're getting is, your, say, plain language description of what you want done. And then, they'll generate a bunch of prompt options, you'll use them, and presumably if you're satisfied with a particular prompt, then they can kind of correlate it to, okay, well then we know what you were trying to achieve, we know the prompt that actually ended up working. That might go a long way towards helping with fine-tuning, like instruction fine-tuning, and making sure these models don't even need that extra step ultimately. That's a big part of this kind of next leap, where you really do want to make the job of prompt engineer maybe not disappear, but you want to reduce the burden on people to kind of come up with good prompts. It's a systemic problem in the field, right? Because it's not just that it's hard to get good at writing good prompts. It's that you constantly have new models with new fine-tuning techniques. Like one model might be trained with like constitutional AI and behave a certain way. Another model might be trained with PPO or LHF, be trained a certain different way. And they all have different quirks. And so you got to kind of spend some time ramping up with every model. And that's just a fixed cost every time you switch platforms. And so, you want ideally, in order to fully democratize this stuff, you want to kind of reduce that burden as much as you can. And I think this is a really interesting data set that Anthropic's going to have on its hands to help bridge that gap. I wouldn't be surprised if we see some work come out of Anthropic that's focused more and more on leveraging this kind of data just to make it sort of the zero shot version of this go really smoothly. And anyway, I think it's an interesting move, and not the first time. We've seen, even in the last month, 2 or 3 occasions, Anthropic coming out with these, I don't know what's called, like user experience modifications, like user interface, user experience design choices that are just different on their platform, where they're creating value not just through the quality of Claude 3 or Claude 3.5, but through the quality of the user interface, user experience. And so I think this is another great bit of low-hanging fruit, a great bit of innovation from Anthropic.
That's right. Yeah, I think it's interesting to see the differentiation where OpenAI seems to be doing more to sort of partner with enterprise customers and pushing more on the model front with things like GPT-4o. Anthropic is much more aggressive on these sorts of features and user experience things. And with this one as an example, right, this is already something that as an AI engineer, you are probably doing in some sort of potentially ad hoc fashion, or you might be using something like weights and biases, which has something similar built in. So it makes a lot of sense for them to build it into the tooling of their platform.
Yeah, and this in a context too, where if you don't play a lot with prompt engineering, you might not realize how far it can go. Good prompt engineering really can elevate. It can make things possible that were impossible before. And so this is very much. It's not just about making better models, but like if your model on its own with no support is a $1 billion market value model, it could create, let's say, $1 billion in value, roughly speaking, in the economy. But it's actually not being tapped for nearly that much value because people don't know how to prompt it right. Like you can really. You could really reduce the effective value of your model just by making it harder to interact with. So I think this is a great way to mine value in language models in a more scalable and automated way.
On to lightning round. First up, we have Figma pauses its new AI feature after Apple controversy. So this feature is the prompt to design AI generator that was called Make Design. And the controversy was that it seemed like it generated designs that were very similar to existing apps, in particular Apple's iOS weather app. So there was this user, Andy Allen, who tried the prompt weather app, and the tool created 3 results that looked identical to the weather app from Apple. And there you go. So it seems like this might have been this might have been trained on a lot of data from existing apps, and that might lead to legal trouble. And now it is paused.
Yeah, which also kind of makes sense, right? Like how would you design this tool, right? Yeah, you'd probably need to train it on actual apps, and so this is what we have. This all came out on Twitter, or X, I should say, where there's a user who came out and basically made this accusation. There was a response from Figma that said, "Look, we use." So this is their defense here is like, "Look, this isn't what happened. We didn't just kind of train it on these apps." They say instead that Make Design, this tool, uses off-the-shelf language models combined with, quotes, systems we commissioned to be used by these models. And I don't know what that means. I have no idea what that means. It kind of sounds like none of this denial seems to have much meat on the bone. I may be missing parts of it, but I did look and wasn't able to find much. He added that the problem with this approach is that the variability is too low. So the variability, presumably this means the variability in the outputs. And if that's the case, this makes me think, okay, so are you kind of admitting that it was overfitting? And if it's overfitting, then doesn't that make it more likely and not less that the designs we're seeing were in fact Apple copies as they appeared to be? So I'm not too sure that this helps the case. I'm not sure exactly what these arguments really mean, but it seems a little confusing. Apparently, they added within hours of seeing the tweet that called them out on this, they identified the issue, which was related to the underlying design systems that were created. Ultimately, it is my fault, says the CEO, for not insisting on a better QA process for this work and pushing our team hard to hit a deadline for config. I don't know what any of this means, but hopefully they, find a process that's less at risk of getting called out for, I don't know if it's copyright violation. I don't know what the status is of training on apps. I think this is a really interesting legal question, kind of in its own right. But anyway, there you have it.
Yeah, and this is a pattern we've seen over and over where, a company releases a feature and then often within hours or days, we see users on X or Twitter point out different issues. And in some cases, there's even been the case of Google having to revert a feature. So I guess in some sense, good that you could crowdsource your QA. Next, Quora's Poe now lets users create and share web apps. So Quora has this AI-powered chatbot aggregator, which is kind of an interface to use various chatbots. And they now have this feature called Previews that allows users to create interactive apps directly within the chatbot conversation. So these can include data visualizations, games, and other applications, and they have support for HTML output with CSS and JavaScript. So basically you can launch like a mini website and share it with other people via link, very much similar to artifacts that we saw from Anthropic.
Yeah, I think this is actually a really interesting play, right? It's like the Anthropic artifacts launch, but it obviously allows you to interact with a whole bunch of different chatbots. And this aggregation function is really important in this space, especially because we're increasingly moving to a world where an awful lot of these models are commoditized, right? Like in other words, you could kind of use one or the other. There's GPT-4 and Claude 3.5 Sonnet. These are both really good at writing code and building apps and all that. That's not to say that there aren't clear leaders at any given time in any specific issue, but often we don't have the time to figure out which is which. And having an integrated platform where you can just quickly test them out in this way in a very informal manner, I think that's a lot of value right there. So yeah, interesting play by Quora, which is not, you don't normally think of Quora as an AI company. And in fact, Quora's base business model, a lot like Reddit, a lot like Stack Overflow, for example, like just a forum, you might think of as being at risk of of being disrupted by a lot of these AI developments, chatbots in particular, for the question answering function. So now, we have this interesting play with Poe as a way of sort of selling the shovels instead in this industry, and having people access these chatbots, these language models through the platform. So kind of interesting, and yeah, we'll see if it takes off. But $20 a month is the price for the premium plan on Poe. We've heard that price point a lot before, right? So that's the your standard issue AI chatbot price point, rough order of magnitude. So there it is.
And the last story for the section: Suno launches iPhone app. Suno is, of course, one of the leading text-to-music startups that has had a web version for a while, and you can pay for Pro and Premier plans. And now they're launching this iOS version of product in the US, basically equivalent to the web version. That's pretty much it. I think makes a lot of sense. One of the use cases of these kinds of things is you have like a funny idea for a song, and you go ahead and just enter a prompt and see what happens. So it makes sense for you to be able to do that on the go whenever you are struck with an idea. Onto applications and business. First, we have Groq U. Groq U, not Groq from XAI, unveils a lightning fast LLM engine. So we've seen Groq before publicize their ability to do really, 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 really fast inference, and now they have announced this LLM engine that allows users to type or speak queries, and Groq responds at a speed of around 1,256 tokens per second, which is up from 800 tokens per second they demonstrated in April. This is, for example, on the LLaMA freebie, some of the open source parameters. And for reference, usually on things like GPT-4, you get around maybe 200 tokens per second. In my experience, 150, 200. So a lot faster than what you get off the shelf.
Yeah, Groq is such an interesting company. We have talked about them before, as you mentioned. A couple of the kind of big developments here is, yes, this is, we're hitting 1,200 tokens per second. That's up from about 800 tokens per second before. That was back in April. Now, so a couple of the big things. So first of all, Groq is offering a console for developers that allow them to port over their apps from basically OpenAI to Groq in seconds using very simple steps. This is all part of Groq's increasing focus on enterprise. So they're trying to get people to switch over from OpenAI, and to the extent that they're now at over 280,000 developers in their community, maybe that's part of what's been working. So very impressive. Lightning fast inference. This is not a training chip. This is just inference. We've seen a couple, right? So this idea of making in this case, this is an LPU, right? A language processing unit. It is custom, specifically built for language models. And we've seen that before. We saw the Sohu chip. I think that was, if not last episode, the episode before, so a couple weeks ago. A lot of these chips focused specifically on inference and not training, and specifically on transformers and language models more broadly. So I think that's a really interesting trend. This reflects, we've been saying this on the podcast for feels like almost 2 years now, but this idea that there's a trade-off. You can choose as a developer, am I going to invest my compute during training time to do train the base model, or at inference time in the form of, kind of agentized designs, getting the model to or querying the model multiple times to get a single answer, to invest more computing power at inference time rather than training time. So this reflects a belief, a structural belief by these companies that is where things are going. This is why you would make an inference-only chip that works specifically for language models, for transformers, and so on. And this is just a really interesting company. The key to this particular chip, the LPU, seems to be they're essentially building in. So there's this thing called SRAM, and it's a memory that sits right next to the logic on the chip. And SRAM is really great. It's super fast because it's right next to the logic on the chip. So rather than having to send your data to some memory bank, through high bandwidth memory or something out, somewhere else, you're able to keep everything really local, really tight, so you can do things very quickly. But one of the challenges is SRAM can be very limited, which means these Groq chips, they're super fast, but they have really, really small memory. So you need a whole ton of them to run even one like LLaMA 7B or Mistral 7B type model. In this case, if you're curious, if you wanted to serve up the Mistral model, I think it was the 7 billion parameter kind of mixture of experts model. You need 576 chips to do that, right? 576 chips versus a single NVIDIA H100 chip. That's kind of this trade-off. And there are all kinds of economic questions that come from that. We talked about those in the previous episode, so go check that out if you're interested. But yeah, Groq's a really interesting company, and they're continuing to kind of push their advantage on blazingly fast inference. For them, the question is going to be, can we get this at scale? Can we get enough of a user base that we can amortize the cost across a massive number of users and then make it essentially cash flow positive? This is a big indication, if they're hitting 280,000 developers, that they are on their way to do that. And that's a very exciting prospect if you're a Groq investor. First of all, if you're a Groq investor, good for you. So anyway, that's I guess the story, and congrats to Groq on a very impressive inference play here.
For sure. And yeah, some very interesting questions that arise from this, and some things to note. As you said, one of the challenges with this kind of technology is memory usage. And it's, to me, seems like you probably cannot extend it to training, just by virtue of training taking up a lot more memory inherently. And we've also seen new model types of all of this exploration of recurrent models that use a much smaller memory footprint. Interesting to see if that comes into play also at some point. And next story, Microsoft and Apple ditch OpenAI board seats amid regulatory scrutiny. So we just covered, I think last week, that Apple was joining the board with observant role. So just observing, which is also what Microsoft has. Well, now both of those are leaving the board. And as per the title of the story, that's pretty much because of antitrust concerns, with particularly UK and EU being concerned about it, but also the FTC investigating the investments by Microsoft and others into Anthropic. So makes a lot of sense that given OpenAI now being closely partnered to Microsoft and Apple, they want to put a little bit of distance between themselves and OpenAI.
Yeah. And amazing that this is just 8 months after the non-voting seat, this seat that Microsoft had on the board was secured in the first place. So this is a very rapid turnaround. And it's also obviously was partly triggered. Actually, these investigations were largely triggered by the OpenAI board of directors drama, right? Where Sam Altman got ousted. And one really important ingredient, especially for this aspect of the story, is what happened after Sam was fired, which was that, Microsoft's CEO, Satya Nadella, offered Sam Altman a position at Microsoft to head up a big AI research group there. You had all the employees at OpenAI signing this open letter saying, "Hey, bring Sam Altman back." And basically, Microsoft was able to completely undercut the credibility of the board in that process by saying, "Look, you can keep Sam Altman fired. We're just going to bring him over to work for us, and all the employees will follow." And so that effectively made it so that, or you might say that made it so that Microsoft exerted a de facto level of extremely high control over OpenAI, despite the fact that they theoretically only own 49% of the for-profit part of the company. And despite the fact that they didn't even have a voting seat on the board, this is still a de facto position of tremendous leverage. So in that context, you can see regulators kind of like going, is there an antitrust thing going on? Are they really, for all intents and purposes, separate and competing companies? And I guess that story is yet to unfold, but the investigations are proceeding apace.
At the lightning round, one more story about OpenAI, and that is that OpenAI and Arianna Huffington are working together on an AI health coach. And this is through a newly funded venture called Thrive AI Health that is aiming to do this ultra personalized AI chatbot that will guide you through making healthier decisions and provide insights through your health metrics. This is led by former Google executives and has already established research partnerships with various organizations like Stanford Medicine. So yeah, it seems like maybe we'll get our own personalized little AI doctors in the future. I guess we'll just have to see.
Yeah, there's obviously a huge amount of value to be created here, right? Like the idea of customized, tailored medicine. It's been around for a long time. I guess this is the big play, and it's interesting that Sam Altman has associated himself so closely to this particular launch. Like this is obviously a high priority for OpenAI. You can kind of see why, among other reasons. You've got the obvious product value here, but also, hey, it's a hell of a marketing announcement after months of OpenAI being dragged through the streets with drama after drama. So kind of a nice palate cleanser, hopefully for them. There's this kind of brief quote that Arianna Huffington and Sam Altman co-wrote this op-ed in Time magazine, and worth flagging in that context. Time has signed an agreement with OpenAI to do this sort of licensing of their content and kind of back and forth co-op on that. So that's I thought it was interesting to note this sort of first time op-ed. She came out and said, consider what it's like to be a busy professional with diabetes. You might be struggling to manage your blood sugar levels, often missing meals and exercise due to a hectic schedule. A personalized AI health coach trained on your medical data and daily routines could provide timely reminders to take your medication, suggest quick and healthy meal options, blah, 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 blah. I think that's actually really cool. One of the big challenges in medicine, if you know anybody in like health tech or doing like medicine startups, is data collection. Right. And to the extent that they're able, and this is going to be an open question for Thrive AI Health, right? Like, how are you going to set up the privacy and security around this? They say they're going to have robust privacy and security guardrails, but we'll get into it. But after we heard about OpenAI and the calls they've been making on the security side over the last year, it's I guess up to us how far we take that comment. But hopefully they do set it up, because I think this would be an incredibly useful application, hugely positive, and would love to see this work out. The data collection piece, so important, right? Our bodies are so high dimensional. Our interactions with the world are so high dimensional that, sometimes you get sick, you don't know what it is. You get allergies, you can't triangulate the source. You have a reaction to a medication or whatever. And so many things are going on. This sort of thing where you have a more comprehensive picture of what the health life of an individual looks like. That's kind of interesting. I wouldn't be surprised if we gain some pretty important new insights, like medical insights, from this sort of activity. So whether it's Thrive AI Health or something else, would love to see something like this succeed.
Right. Yeah. And it'll be interesting to see if it can succeed as a health coach. Not only will it have to provide insights, it will have to be able to guilt trip you, or, maybe not guilt trip.
Have you ever used Duolingo, Andre?
Exactly. It will need to make sure you want, or at least are incentivized to make those healthy decisions. And that's still an open question. However, AI can do that, but certainly OpenAI is in a place to try. And next, we have exclusive AI coding startup Magic seeks 1.5 billion valuation in a new funding round. The startup Magic is developing AI models to write software, and they are in talks to raise over 200 million in funding that would value the company at 1.5 billion value. And this is coming from a company that has no revenue or product for sale. The startup has about 20 employees and was last valued at 500 million after a fundraising round in February, and they have already raised 140 million since being founded in 2022. So certainly we're seeing still some massive rounds of the sort we've seen with Stability and many other companies in the past couple of years, although I do think maybe there's not quite as many of those, and coding seems to be one of the areas where there's still a lot of money flying around.
Yeah, part of the claim of the magic behind Magic is that they're going beyond they say just beyond the traditional transformer model, whatever that means, right? So I don't know if that means that they are partly based on the transformer and maybe there's like a Mamba tie-in, or maybe, it's something completely different in part or in whole, but it's kind of an interesting little note. They don't give much information about that. This is a big fundraising round, $200 million on 1.5B. Like, that's a lot of money. The investors are no joke. We've got Jane Street on the cap table. We've got Daniel Gross on the cap table. You might remember him as having participated in the Ilya Sutskever's kind of latest company. He's a co-founder with Ilya Sutskever in Safe Superintelligence, SSI. So there you go, Daniel Gross, DG, really impressive investor. Nat Friedman, of course, as well. So yeah, it's a hell of a round, and it's not hard to defend these kinds of absurd valuations. I shouldn't call it absurd, but absurd sounding valuations. When you look at just like the value of software, right? The value of software development. If you're making a half credible case to investors that you're going to be able to automate or own some chunk of software, like, that's a lot, right? That's a lot. We've seen proof of existence for the fact that these kinds of models can generate value through, GitHub Copilot and other similar tools. And so now, it kind of makes sense. The other thing I'll note is this is a startup with 20 employees, and its last valuation was $500 million. That was back in February. So you have 20 employees, potentially. You're looking at, 1.5? I said, $1.5 billion valuation. If I told you 5 years ago that we were going to have companies with 20 employees at $1.5 billion valuations, like, you would have been liable to laugh me out of the room, right? This is just nuts. But it is consistent with, when I talk to friends at the Frontier Labs and stuff, they're like, we're talking about, when are we going to have the first $1 billion company that's got one employee? Like, that is an actual, in some cases, it's an actual sort of like milestone on their path to AGI, because of what it means about how much you can automate and scale. So I think this is just a really interesting data point there, really interesting investors, and a bloody big round.
For sure. Speaking of VCs, the next story is Sequoia and Andreessen Horowitz clash over AI chip supplies amid the Gen AI boom. So recently, Andreessen Horowitz, one of the very big VCs that invests in technology in Silicon Valley, announced that they are stockpiling over 20,000 GPUs to support their portfolio companies. They have invested in at least 19 generative AI deals with a value of about 1.3 billion over the last 2 years, and they have raised 2 dedicated AI funds on this sort of stuff. So part of a need for the stockpiling of GPUs is basically to get a competitive advantage in getting sort of companies in their portfolio. And once again, it's one of these kind of weird things that has come about with AI, and one thing you wouldn't expect VCs to go for.
Though I will say, in the world of startups, there are VCs and there are VCs, right? And the difference between your absolute top tier, your Andreessen Horowitzes, your Sequoia Capitals, and everybody else is often, really good capital allocation. Obviously, they're just really good at betting on good companies, but they also do tend to offer value-added services. There's this old joke in Silicon Valley that a VC will tell you that they're a value-added investor, and it's kind of like completely meaningless. In this case, though, for the top tier ones, they really are value-added, not just for the networking value, but for things like this. They'll look at where the market is headed, and they will anticipate that need, and on behalf of their companies, they will make acquisitions like these 20,000 GPUs. This is also, it's not the first time that we've seen GPUs used in this kind of weird semi-financialized way. We talked about this last August, but CoreWeave, which is this cloud service company, ended up raising over $2 billion in debt using H100 GPUs as collateral. So this is like the financialization. In a way, you can think of this as compute becoming actually kind of like the currency of some of these AI investments. Like your investments are denominated in a weird way, partially in flops, Like you can start to think of it that way, which is interesting from a macro standpoint. It sounds awfully science fiction-y. But yeah, Andreessen basically doubling down on this thesis that generative AI is going to keep getting better, keep becoming a bigger and bigger story. They famously were kind of late to the AI game because they were spending all their time investing in crypto. And in fact, when I was at Y Combinator, that was the big crypto batch. And a lot of my batchmates, ended up raising from A16Z on these crypto plays. Now they're focusing on AI. I think this is personally just a much better play, but that's my bias. On the flip side, Sequoia came out with a piece basically saying kind of not quite the opposite, but a lot of skepticism. And we think about the two of the best firms, VC firms in Silicon Valley, it's absolutely Sequoia Capital and Andreessen Horowitz. When you look at Sand Hill Road, the stretch of road that the VCs are all on in the Valley, those are the two big names. Sequoia making this argument that, look, outside of ChatGPT, how many AI products are consumers really using today? And they write this post where they make a whole bunch of arguments saying like, look at how much value you get from Netflix, and you're paying them $15-16 a month, Spotify $12 a month. We often use these services all the time. Long term, they're saying AI companies will need to deliver significant value to justify this continued spend. And they're calling out specifically, and I think this is really important, this problem that they flag of the missing $600 billion in this ecosystem. If you look at the amount that's been spent functionally on essentially data center spend in the industry, it's about $600 billion that we're in the hole for. And we need to show enough value to justify that. There's got to be enough consumer revenues. But where are the revenues at? Well, OpenAI through ChatGPT has the lion's share, $3.4 billion annualized. That is a tiny, tiny figure compared to the $600 billion that's being spent on data center spend here. There's a long tail, obviously, but it's an indication, and Sequoia would know this, there's an indication that the repayment is just not there right now. And this is troublesome because a lot of people make the argument it's okay if the repayment hasn't come yet. People are stockpiling GPUs because more GPUs is going to pay off later. And the challenge here is, among other things, you've just got depreciation too of the values of these GPUs, right? The H100 ages out. It becomes the B100. So it's not the case that by spending $100 million on acquiring H100s today, you're actually you're creating you're holding on to $100 million in value. That value depreciates over time and quite quickly with these GPUs. So a whole bunch of really interesting arguments about why we might expect this space to get increasingly commoditized. We've talked about this actually on the podcast before in the context of open source companies that just pump out these models. And so much of this is being commoditized. You have to ask the question at a certain point, where is your moat? Where is the actual value generation and value capture? And both of these things are in play to a certain degree. Don't get me wrong, I still think scaling is going to work. I think that perhaps the core argument here is in part that there are going to be a small number of winners, and that an awful lot of the money here that's being spent is actually being wasted. It's mostly VC dollars as they're lighting their giant checks on fire. That's how Silicon Valley has worked historically, but it's still kind of useful to track that. And it may or may not be true, but this is Sequoia coming out making the kind of opposite case from what we've heard from Andreessen.
That's right. I may have misspoken a bit in implying Sequoia is doing the same thing. In fact, the clash there in the title is referring to this blog post that challenged the idea that we should invest so much money in GPUs. And it was titled AI's 600 billion question that, as you said, was sort of saying we've invested so much money in GPUs, are we expecting to actually get all this money back in returns? And the answer is maybe not. And interesting analysis for sure from Sequoia. And speaking of GPU investments, we got a story from Elon Musk, who has revealed plans to make the most powerful 100,000 NVIDIA GPU AI cluster. So another announcement of what xAI is planning to do, apparently to keep training their Groq AI model. There was talks of xAI partnering with Oracle for their cluster. It seems that's probably not going to happen. And the system, which will be using NVIDIA chips, could cost as much as $9 billion. So it might cost less. We'll see. So certainly ambitious, and it'll be interesting to see if they can pull off getting this many NVIDIA GPUs.
Yeah, I was kind of trying to square away in my own mind what they're referring to, like which clusters are referring to what. So here Elon's talking about 100,000, apparently it's H100 GPUs. That's what the article says anyway. And to make us, as he put it, the most powerful training cluster in the world. So there's this 100,000 H100 GPU training cluster. Then perhaps separately, they say, there's an announcement that Elon made last month that they had plans to build this multi-billion-dollar, this $9 billion system you just talked about. That would be apparently 300,000 B200 GPUs. So this is kind of the next generation on the GB200 platform. So I think that might be the idea. And if so, I think the breakdown, I could be wrong, I think the breakdown might be these 100,000 H100 GPUs. First of all, they're going to be able to get them much faster because the H100 is already at scale production, whereas the B200 is not. So they're going to get those faster. They'll be able to train them quicker. And maybe that's just a training cluster, and maybe the 300,000 B200 GPUs are for both training and inference. I'm not exactly sure, and it's not clear from Elon's statements what the distinction is between those two in terms of use case. But yeah, certainly interesting as well that they are parting ways with Oracle. So this is Elon basically saying, "Hey, we want to bring this in house." Apparently, they're like xAI is going to design these data centers themselves, which brings them in line with what some pretty well capitalized competitors are doing. Right? You think about data center, like in-house data center design and AI training. You're looking at your Microsofts and your Googles, that sort of thing. So kind of interesting that this, in relative terms, is very small company xAI, in market cap terms at least, is going to be competing on that basis. They're going to have to hire a whole bunch of hardware experts. I'm sure they already have, but that'll be part of the play here for sure.
Yeah, good catching me on there with apparently multiple planned clusters and not just one. And it seems friendship ended with Larry Ellison, and now Jensen Huang is my new best friend here from Elon Musk. Yet another story on acquisitions. This one is AMD planning to acquire Silo AI in $665 million deal. So this is a Finnish AI company, and AMD is going to buy this company apparently to enhance their software expertise. There's apparently 100 PhDs and 300 employees coming from Silo AI to AMD. And AMD, of course, as we've covered, is trying to catch up with NVIDIA, is trying to get their chips competitive and used more. So certainly a big investment on that front.
Yep. Philips, Rolls-Royce, Unilever, a bunch of important investors joining the cap table there. Maybe, I should say who are already on the cap table. So not necessarily your like traditional AI investors, but certainly people who know their way around things like hardware. And so that's kind of cool.
And next, AI robotics startup raises $300 million. This is the Pittsburgh-based AI robotics startup Skilled AI. This is their Series A, and they are saying that they're developing general-purpose robotics models that will be low-cost robots used in various industries and applications. And the valuation is now $1.5 billion. Relatively new company, so they are not quite at the stage of Figure and 1X, these other companies that are developing humanoid robots. But certainly this deal showing that the enthusiasm for general purpose robotics companies seems to be still there, as we've seen kind of this year really being the case.
Yeah, this is another $1.5 billion valuation fundraise, and it's a Series A. So, Jesus, I mean, Series A, $300 million Series A. I'm old enough to remember when that was would have been absurd. 5 years ago, this would have been nuts. No indication of how many employees they have right now, but this is a very interesting play. Like, they're coming out of stealth with this, so we don't know much about them. what we do know is they've got a foundation model that they've built. They claim it's unusually robust and meant to scale across a whole bunch of different robotics platforms. So the idea there, I'm just quoting here from their launch release, as opposed to vertically designed robots that are built for specific applications or only deployed in isolated or constrained environments, our model serves as a general purpose brain. It's demonstrated unparalleled generalization and emergent capabilities across a diverse embodiment of robotics scenarios and tasks, including manipulation, locomotion, and navigation. That, of course, the big problem in robotics, where you need to gather task-specific data. That's usually the big challenge. We've seen attempts to kind of break out of that mold with, Google DeepMind comes to mind, where, their Gato system, they trained it to do a whole bunch of different tasks, a subset of which were robotics, so certainly dozens of robotics tasks. But this is the claim that, hey, we've got an unusually robust system. We don't know how it's being done. They're calling it a foundation model. Is it transformers? Is it something else? We don't know. But one thing to flag is that the caliber of the investors in this round is stellar. Like, this is, if you were looking for an indication based on investors that there was a company that was worth watching, this really is it. We've got Jeff Bezos, obviously, through Bezos Expeditions, which is his fund, but other participants, Sequoia Capital. This is like Silicon Valley's basically number one VC, Menlo Ventures, General Catalyst, SV Angel. There's Carnegie Mellon. There's CMU on the cap table for some reason, along with Lightspeed, SoftBank. It's the who's who. I don't see Andreessen on there. That's one big name. There aren't that many that are missing. Let's say this is really impressive. So I would just say, if these investors are seeing something here, yes, there's a hype cycle for sure. But $300 million is it's a decent amount of money. It's not a huge amount for these guys too, but still, it's a big round, big valuation. And this is a team, by the way, that does explicitly have that AGI goal in mind. They're making the argument, as many have, that if you want to achieve AGI, language models are not enough. Just being purely into the world of bits is not enough. You need to move into the world of atoms. You need to have systems that interact physically with the world. And so that's the claim. It's a team, they say, with former folks from Meta, Tesla, NVIDIA, Amazon, Google, and blah, 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 top schools, all that jazz. So basically, if you're looking for an all-you-can-eat buffet of impressive credentials, this is your startup. So let's see how they roll.
Yeah, looks like the founder and CEO is Deepak Pathak, who was an assistant professor at CMU doing research on computer vision and robotics. So maybe that explains the location of Pittsburgh for the founding and some of those details.
It's a very glamorous city of Pittsburgh, yes.
And last story for the section, we have Intel begins groundwork on Magdeburg chip fab. This is Fab 29 in Germany and is meant to be one of the largest and most advanced chip fabs in Europe. And the construction of it is beginning despite some of these environmental objections and some subsidy approvals by the EU. So, as we know, the ability to fabricate chips is a very important component of AI progress, and Intel is one of the relatively few companies in the world who can do advanced fabrication of the sort. So presumably this fab would be important to that.
Yeah, this is part of Intel's hope that they're going to be able to leap ahead of companies like TSMC that right now has complete market dominance at the leading edge node, right? So the smallest, highest resolution fabrication process. So right now, Taiwan Semiconductor Manufacturing Company just absolutely dominates that. Intel trying to break into it. They have their 14A, that stands for 14 angstrom. That's equivalent to 1.4 nanometers process that they want to start running apparently in late 2027. And their 10 angstrom, their 1 nanometer production node. This is, by the way, this is, in fairness, marketing terminology, but if it was really 10 angstroms, that would be like 10 hydrogen atoms in size. That's kind of the feature size that is being teased, at least in that title. So those sorts of processes, like if they hit that on that time horizon for scale production, they absolutely could be starting to get competitive with TSMC. So this would be a big deal. And it's especially a big deal because the idea here is to have this fab on German soil, right? So you actually really want this stuff not on the island of Taiwan, which is like a super crazy geopolitical hotspot. You want it somewhere else, whether onshore, sort of in the United States, ideally, or in sort of Western aligned countries. That's the play here, and certainly what NVIDIA has been responding to is demand from governments. But there have been environmental protests, apparently 13 distinct objections from environmental groups and municipalities. This is part of the challenge, right? You're trading off explicitly the environmental concern for the national security concern. And this has already resulted in significant delays on what is, I will say, like a key piece of national security infrastructure that now has been pushed back in its launch date to by, it looks like, a couple of years potentially. They're now saying the latest reports suggest a new schedule estimating 4 to 5 years for construction, with production now expected to start only between 2029 and 2030. So when you think about all the red tape, obviously a big issue in when it comes to onshoring of semiconductor fab in the United States. Also, it seems an issue, unsurprisingly, in the EU as well. So there you have it.
And on to research and advancements. No open source stories this week because there's a lot of these other stories. The first paper we are covering is titled Learning to Learn at Test Time, RNNs with Expressive Hidden States. So yet another paper looking again at different class of models than transformers that leverage recurrence. This one is introducing a new idea of what you represent this hidden state with. So in recurrent models, the idea is you keep a memory of sorts of everything you've seen in a hidden state that you keep kind of passing along and updating as you go. And typically you train the weights for that update for your sort of memory formation at train time and use that at test time. The idea of this paper is that instead the memory itself can be its own sort of mini machine learning model, that instead of having a fixed way of updating it, you can instead treat it as a thing you can train on the data as you go. So you can kind of train the non-memory component of the network, and then even if you freeze those layers, the thing that remembers the data that you've seen can continually be updated via self-supervised training. And that's why you can train even at test time, at inference time, because you're essentially adapting your model to the input and seeing what you can remember. So that's the idea. I think it's very cool. And as you might expect, on the evaluations, they say that it works really well.
Yes, it does. It does appear to work really well. I think they have a plot. It just says really well. So it's a great development. This is one of the I think one of the most conceptually interesting papers I've seen in a long time. As you said, there's this idea that, so just to take a step back, right? If we talk about transformers, one of the big challenges with transformers is just scalability. The way transformers work is essentially they'll kind of like they'll take a look at different words in the prompt and kind of look at their dependency on each other, which roughly speaking gives you this kind of quadratic relationship. You have to care about every combination of every different word. So as you grow your context window, now you're quadratically increasing the amount of computation that's required in order to train this model. And so the whole idea behind these state space models, these recurrent models, is, as you said, as the model, imagine having instead a fixed context window that's maybe on the smaller side. And as you're reading more text, you slide that window along your text, but you don't necessarily forget everything you've seen. As you move along, you essentially offload some of the stuff you've learned from past text that you've looked at to this memory. And that memory gets updated as you slide along that window. Now, the memory itself is, as you said, there's like all this static weights that kind of determine how that memory is formed. What they're proposing here is essentially that memory block itself is going through a training process at inference time. So you train your model, you finish the training, all the weights are frozen. Normally that would be the end of the story, and then you use it. But here, the memory piece, as you're training your model on a new chunk of data, long string of text, essentially it's doing auto regression. So it's being trained like to do next word prediction and adjusting a separate set of weights, this kind of sub-model within the model. And that, one of the big things I find interesting about that, we talked just earlier today about the trade-off between training time compute and inference time compute. Well, this is some middle ground, right? Like, is it training time compute? Is it inference time compute? It's kind of both. The model is doing some sort of training activity at test time. So that's really cool. They highlight that this model has a bunch of favorable scalability characteristics. So they compare it to Mamba and they compare it to the transformer architecture. There are a couple of really interesting curves there that show, sort of noticeable, assuming that they have enough data to kind of be confident about these curves, noticeable improvements in scalability. So as you increase the number of flops that you invest, the amount of compute that you use to train the model, the performance, as measured by essentially next word prediction accuracy, this perplexity score, improves faster if you use the this kind of alternative training strategy. One thing that I'll highlight that is especially interesting here. So the big challenge with Mamba, like one of the ways in which it fails, in principle, yes, you can accommodate effectively it's like having an infinite context window, because as you read, you're updating your memory continuously. And you can just keep doing this indefinitely, right? Whereas transformers, they have to hold the whole thing in their head at a given time so they can look at all the cross correlations between different tokens in the input. Well, the problem with the memory approach, the problem with the Mamba approach, is that your memory kind of gets overloaded after a while. It just, like, if you're going to read a ton of text, eventually it just doesn't retain, like, some stuff gets lost, new stuff comes in, and eventually you do lose the information that came before. And so you have this issue where, as they measure that around 16,000 tokens into the context window, it starts to no longer scale well. Like, it starts to lose the information that was gathered earlier on. This technique doesn't do that, or at least it does it a lot less. So it's essentially a way of adding an extra layer of filtering before you add stuff to the memory in the Mamba architecture. Instead, what you're doing is you're pre-filtering it to identify relevant information. So you're applying essentially an information density screen to make sure that your memory only holds on to the very most valuable things. That's really conceptually what's going on here to make this better when it comes to actually retaining relevant information in that context window. So I think this is really interesting. I think it's something that I haven't seen before in this space, and a bit of a compromise here between, as I said, training and testing time, training and inference time compute. So another degree of freedom.
Right. And lots of interesting implications with this one. One other kind of challenge with transformers is they are unable to learn at test time. They aren't kind of able to update their own parameters based on the data they're seeing. So this, in some sense, addresses that. And looking back at history, right, the transformer approach was introduced originally for RNNs to update their memory in a better way, right? And then transformer attention is all you need basically said, well, forget the hidden state, let's just use attention. This whole trend of going back to RNNs is very interesting, and it is very possible that transformers will in the end be just one component with recurrence still playing a part. And next paper, data curation via joint example selection further accelerates multimodal learning. So this is about multimodal contrastive learning with joint example selection, which is an approach to selecting which batches of data, which kind of subsets of your training data you are going to use to update your model at any given time. And it's kind of pretty well known that certain batches of data are going to get your model to learn faster. Typically in training, you just sample randomly, essentially, from your data distribution and get batches from all around the training set. Well, this is showing a relatively straightforward way to be able to select the best batches of data. And that leads to these models being trained with up to 13 times fewer iterations and 10 times less compute. So there you go. It's a new way to train more effectively. We're using less data, and presumably is something these companies are looking at. This is coming from DeepMind, presumably a method to optimize kind of compute spending that industry scale companies are putting into these large models.
Yeah, absolutely. And this is actually quite a fundamental paper, and I wouldn't be surprised if it has some real implications for the way training is done in the future. So yeah, the core idea here is, normally when you do this sort of random sampling that Andre, you just described, you're kind of picking your samples one at a time to create your batch, to create your kind of training batch that you'll then feed into the model for one round of gradient updates, for one round essentially of model weight, model parameter updates. The argument here is going to be, well, even if, and by the way, sometimes people do apply a filter, they often do, to pick those samples, right? They try to pick samples that, or for various reasons they suspect will be useful for the model to learn from. And what they're pointing out here is, well, that's one way to look at the problem. But in reality, the model is learning not from one sample at a time. It's learning from a batch of samples. And the relationship, the statistical relationships between samples in a whole batch really matters in terms of the model's training efficiency. And so we ought to be thinking at the batch level. We ought to be evaluating the learnability of an entire batch, these sub-batches that we're going to feed the model, instead of thinking of it as a sample by sample thing. And they show that by doing this, you really get a big lift in your training efficiency. They come up with some really interesting selection criteria that are very intuitive for picking what samples ought to be included in a batch like this. So one of them is they have this, so they use a cheap model that can quickly predict, for very low resource cost, they can kind of predict how well the main model, which is known as the learner, how well the main model will perform for that sample. So think of it as like an approximation to the main model you're trying to train. So you got this essentially reference model that's the approximator, and then you've got the learner, the thing that's being trained. And so the idea here is, let's pick samples that are hard for the learner, for the model you're trying to train, the samples that it will find challenging. You don't want to feed it samples that are really trivial, because then it's not going to learn anything from them. So you want to focus on picking samples that are hard for it. Now the problem is, if you do that, then the challenge is that your model may actually end up getting fed a lot of noisy data that you literally can't learn from. That's one way that a model could struggle to learn from something, is if there's no actual correlation to be learned. And so you need a way to compensate for that. And the way they compensate for that is that they'll pick samples that are also easy for a reference model that's already been trained. And so in this way, you're kind of able to determine, okay, these samples are both learnable and also hard for the learner right now. And they combine those two essentially metrics that represent those two things into one score called the learnability score. That's ultimately what they're going to use to qualify samples. And they're going to do that again, not by looking at individual samples, but looking at the kind of sub-batch level, kind of looking at these batches of data they're going to actually feed to the model. And that way they also are accounting for, how does this bundle look to my model? How does this bundle of data, how is it predicted to improve my model's performance? So just really impressive, as you said, massive efficiency lifts, right? 10x fewer flops during training. In other words, 10 times less compute. This is a really important lift in a world where we're talking about, billion-dollar AI training runs. Anything you can do to bring that cost down has really, really big implications. So very, very interesting paper.
Right. And as you pointed out, this idea of not randomly selecting training data, not so unusual. There's hard negatives and things like that people do use and have used for a very long time. Even here, their learnability metric is coming is coming from a previous paper from 2022, prioritize training on points that are learnable, worth learning, and not yet learned. Fun paper title. And presumably one of the big advantages with DeepMind doing this is they are able to scale up quite a bit. They're able to train on big models and demonstrate this very large effect on compute used. On to the lightning round. The first paper is Copy Bench, measuring literal and non-literal reproduction of copyright-protected text in language model generation. So they are looking at both generating literally text, so word for word, essentially, on text such as books. But they also look at non-literal copying that isn't really doing word for word copying, but could still be considered plagiarism. And so they demonstrate with this new benchmark that as you go larger, as you go to models like 7 billion, you get increases of literal copying rates apparently from 0.2% to 10.5%. And non-literal copying is going up from 2.3 to 6.9%. And that's comparing LLaMA 3, 8 billion to 70 billion. And that's a trend we've seen before. I think that our larger models kind of do copy more. And they also introduce some techniques for doing it less with alignment and inference time mitigations. Apparently, those mitigations reduce literal copying, but not this indirect copying.
Yeah, and in fact, they may increase, right, the non-literal copying, which I think is both to be expected and unfortunate. The reason it's to be expected is we often see this. If you have a metric that you're optimizing for in your training process, you'll often find that it will get improved at the expense of other metrics, right? Essentially, this is sometimes known as Goodhart's law. At least this is the economics field version of this phenomenon, where if you optimize for a metric really, really hard, you'll eventually find that rounding to a rounding error, all other metrics go to shit. So the idea here is you want to be really careful that your training process accounts for these things. The fact that we've been so focused on training out literal copying is not necessarily a good thing. The non-literal copying, which courts care about, by the way, in assessing the degree to which reproduction has occurred for copyright purposes, that matters. And so you actually do want to make sure you're tracking both of those metrics at the same time. And again, you're kind of playing a game of whack-a-mole unless you're tracking both of those metrics. And to your point about this idea of models being scaled more and then doing this kind of literal copying a lot more. One of the reasons for that is just model capacity, right? They're able to hold a lot more facts about the world. That means they are more prone to overfitting. They're more prone to, you can actually, if you imagine having a really, really tiny model, it just doesn't have the capacity to remember the name of every character in Charles Dickens, right? So it's not going to hold on to that. It's forced to just focus on generalizable facts about the world. Whereas the larger you make that model, the more it's able to kind of hold all kinds of highly specific facts. And then you see kind of this risk of literal copying pop up more. And again, that's distinct from non-literal copying, and which also gets worse, but it's along that spectrum. So yeah, an interesting paper, and it's something that now we have to ask the question. Well, we've got a lot of companies generating a lot of content that they've presumably checked for literal copying risk. But what about exposure to non-literal copying risk, right? How many products, how many written artifacts are out there now that have used these models on reliance on the idea that they're not going to have a risk or as much exposure as they might realize. So really interesting paper, and I'm curious if we'll see it referenced in a court ruling at some point. I mean, I'd be surprised if we did, but the underlying concept is really interesting for that purpose. Yeah.
Yeah, and to that point, this is one of the contentions in the New York Times lawsuit against OpenAI, that their model ChatGPT reproduces New York Times articles verbatim. So very much a needed benchmark, it seems. Next up, just read twice, closing the recall gap for current language models. And this is again addressing the problem that we covered before, where with a fixed memory, one of the challenges with recurrent models is trying to store and recall all the information you've seen as you get to longer and longer input sequences. So what this paper shows is you can repeat the context in different orders, and that leads to significant improvements in context learning and being able to recall your data. And yeah, that's the gist of it.
Yeah, I think we saw talked about a paper, I think it was last week, that was sort of similar in spirit, where they were talking about this like U-shaped sort of context detection or context sensitivity in a lot of transformer models, where the information that's contained early on in context gets a lot of attention. The information that's contained late in the context gets a lot of attention, but the stuff that shows up in the middle doesn't. And in that circumstance, I think they were talking about normalizing for that effect and strategies to resolve that. This is another technique, right? You say, okay, I'm not going to try to resolve this at the level of the algorithm. I'm going to just like shuffle the contents in my context window, and that could be another interesting way to solve the same problem. But yeah, I'm really I'm interested to see which techniques end up winning through in the long run. But obviously, huge implications for things like retrieval augmented generation, which depends on the model's ability to reliably retrieve and sort of objectively pick out which sources are relevant to a particular user query. You want that to happen independent of the order of the documents that you put in this context. So yeah, I think it's an interesting kind of addition to that saga.
And speaking of memory and knowledge in models, the next paper is Code Update Arena, benchmarking knowledge editing on API updates. So one of the limitations of LLMs such as ChatGPT is once they're trained, their knowledge is essentially static. The way you present new information they did not see during training is you can just sort of mention it in the input of a model prior to asking it to do whatever you want it to do. And that might work, but sometimes it might not work. In this paper, they say that, let's say you want your model to use API function calls, so use some sort of interface that changes over time. They introduce a bunch of tasks where they want LLMs such as GPT-4 to generate executable function updates for various types, 54 functions from different Python packages. And what they show is that just doing the standard approaches of prepending knowledge or knowledge updating don't seem to work very well. So pretty much a specialized benchmark for that application.
Yeah, this really makes me think of the paper we were just talking about with that test time training, TTT paper. Did I get that? Yeah, test time. Yeah, I think that was it, right?
Yep.
Yeah, right. Like the big challenge is these models. Like the solution to this is, okay, well, fine tune your language model on the new documentation for the updated code base, and that would probably work better. But of course, that's more time consuming. And so the idea, or more resource intensive. So the idea of going with a test time training approach where you actually can update by default, the expectation is that you're updating admittedly a very small number of weights, but you are doing weight updates in real time as the model learns outright, not in context learning, but like learns from the context. Is maybe an important strategy for solving for these sorts of problems. But this is really interesting. And the moment you create benchmarks, right, people start to optimize for them. So I wouldn't be surprised if we started to see some pretty quick improvements in this direction. But it also reminds me a bit of François Chadet's AGI benchmark, right, that he put out. Kind of people starting to identify the small number of but fairly important nitty gritty problems that transformers struggle with embarrassingly still. And trying to pin down, in this case, again, it's like a bit of a system two type thinking problem, right? Like, how do you reason about new documentation that changes the lay of the land, changes the game board, and how do you actually apply that to your problem solving? So I think that this is actually a pretty important benchmark, and I think it's a spiritual cousin of the François Chalet AGI benchmark in a certain way.
Next up, composable interventions for language models. So this is dealing with test time interventions, and these are techniques to get your model to do the right thing, to not say bad things, to have factual accuracy, and so on. And what this paper points out is we've seen a ton of different test time interventions introduced, but no real exploration of when you combine a few of them in practice, and that is presumably something you would do if you're trying to put these models into production. So they introduced composable interventions, a framework to study the effects of using multiple interventions on the same language model. And they study 310 different compositions and uncover different meaningful interactions via different intervention methods.
Yeah, so they're going to look at a couple of different families of interventions, and they call them interventions. I'm trying to remember. I think one of the authors had this like medical background or something like that. It just reminds me of that, and you're thinking of a surgical intervention or a medical intervention. So times when you're going in and messing with the guts of your model in some way to change its behavior, they look at three. So they look at knowledge editing. Basically, this idea of changing the knowledge, updating the knowledge that your model can represent. This is done using techniques like LoRa, where you might add some adapters to your model to add to their knowledge. So knowledge editing is one. Unlearning is another, where you can cause a model to forget stuff that it has previously learned. The way that this is often done is using techniques like gradient ascent, not gradient descent, which is usually what you use to train these models, but gradient ascent. In other words, instead of training a model to reproduce text, right, in this autocomplete way, autoregressive language modeling, what you're going to do is train the model to not create certain kinds of sentences. So that's one method to achieve unlearning. So we've got knowledge editing, we've got unlearning, and finally, we've got model compression, right? And we've talked about this a lot on the podcast, weight pruning, getting rid of unnecessary weights, and quantization methods, representing your model with essentially a lower resolution. And one of the key things that they show is these things, so it matters, the order in which you carry out these transformations matters, right? The order in which you, carry out these interventions matters. So if you do stuff like knowledge editing or unlearning, and after that you compress the model, you're going to find that your performance goes to shit, basically. Now, if you do the compression first and then you do your knowledge editing or your unlearning, your results are a lot better. And so there's some metrics that they kind of invite us to start tracking around the order sensitivity of your interventions, and just to try to understand, okay, are these interventions actually just kind of like reshuffleable without perturbing the overall result, or does ordering matter? And it's fairly intuitive that compression really nukes your performance. Like if you've delicately set up your model just so, and then you compress it, that's going to mess with some of the delicate interactions between, for example, your LoRa adapters and your base model if you're doing knowledge editing. But in any case, so doing the knowledge editing after the fact, probably a good move. They also highlight this really interesting fact that traditional evaluations like MMLU, so standard benchmarks for like how well is my model doing, often don't detect a loss of performance after these interventions have been performed. But you will often see that, like, if you look at if you have a bunch of these interventions stacked together, let's say you do knowledge editing and then you do compression, your MMLU score might remain constant, but after you do compression, the knowledge editing score, the one you use to fine tune the model for, basically goes to crap. Right. So essentially the problem is the compression can do damage that isn't detected if you just look at traditional eval. So whatever metric you used to introduce that new ability or to perform that intervention, you need to keep tracking that specific metric as you add more interventions, as you chain them together. And they're pointing out basically in this paper that this means we need to be more comprehensive when we think about evaluating models following these interventions. We need to continue to monitor all the metrics that we have intervened to improve over time, because we can't just say, okay, well, the MMLU score is still what it was before, so everything's probably fine. No. You got to have this kind of multi-metric approach. So I thought that was really interesting. There's a whole bunch of good stuff in the paper. This just, by the way, becomes more important over time, right? Because models are changing a lot. The software environment around models is changing a lot, the data environment. So we find ourselves often wanting to make a lot of these interventions, these changes to a model without retraining it from scratch, because that's super expensive. And so our ability to chain these changes, these interventions together robustly becomes more and more important over time. Anyway, I thought this was really interesting. And last thing is, knowledge editing and unlearning turns out are highly composable. In other words, reshuffleable. The order there doesn't matter. So some of these interventions can be reshuffled with impunity. Others, like compression, can really affect the outcomes depending on the ordering.
And the last story for this section, covering the paper, PAM, Predictive Attention Mechanism for Neural Decoding of Visual Perception, covered in the New Scientist in an article titled Mind Reading AI Recreates What You're Looking At with Amazing Accuracy. So that's the gist of a paper. They introduce a new technique for taking in fMRI recordings of your brain. And if you look at that data while the person for whom the fMRI data is being generated, while that person is looking at a photograph, you can train a model to then reconstruct what they're seeing in a photograph roughly from the data. And this is introducing a new technique that allows you to focus on relevant parts of the brain and produces pretty impressive reconstructions for the most part. So they're not super accurate, so it's not reproducing the pixels that well, but it gets at the gist of what you're looking at. So if you're looking at a spider, what you get is a spider-looking thing. If you're looking at a goldfish, you're going to get a goldfish of what might look kind of weird. So not quite mind reading yet, but certainly able to roughly know what you're looking at.
Yeah, I would say what do they have? They have 5 examples here. It's like in 4 out of 5 of these examples, I think I would be able to correctly identify the object verbally. Like, I think you could say it's looking at a fish, it's looking at a spider, it's looking at a boat, it's looking at a landscape. One is kind of messed up, but what are you going to do? It's kind of remarkable. We've seen stuff like this, right? Like there have been other papers before. Some of these experiments carried out on humans, where you get sort of similarly interesting results, shall we say? So this is. This is where the space is going. All right. This is good. Everything's good, man. Yeah. Everything's fine. We can read minds with AI. Everything's fine.
Yeah, I mean, if you can record good fMRI data, presumably, which isn't necessarily easy, but
true. You think about the possibilities for interrogation, and they start to get really fun, don't they? But yeah, I mean, it still requires a lot of stuff, but there are impressive brain-computer interfaces being developed. So not out of the question that we get somewhere very interesting in the kind of medium-term future with this stuff.
And on to policy and safety. We begin with a safety-focused paper, and the topic is covert malicious fine-tuning. So this is a new idea where you can create a seemingly harmless data set, but when you fine-tune a data set, the model learns to respond to harmful requests with harmful responses. So you can apply this to GPT-4 when you fine-tune it on the new data. The new model is then able to respond to harmful instructions 99% of the time. And the fine-tuned model is able to avoid detection mechanisms by common defense mechanisms, such as dataset inspection. So a new way to make your models do bad stuff and get around the restrictions.
Yeah, I really like this paper. I really like the strategy. And I think it is a qualitative shift in the challenge of building safeguards for language models around this sort of thing. If you think about previous jailbreaks, what have they looked like? They've looked like, people appending specific weird character strings to the end of their prompts to get the model to actually just acquiesce and give the output that they want. Stuff like that, it's pretty readily detectable. It looks anomalous in that way. Well, so the way this works is essentially step one, you're going to you're going to fine tune GPT-4 to, let's say, speak or understand a different language or a different way of encoding language that you're going to invent. So some kind of coded way of communicating. In this case, they play around with a cipher, which I like because my dad was a big World War II buff, and coding ciphers are always fun. So this basically, the way the cipher works is, imagine whatever you're going to write, whatever text you're going to write, like take the ordering of each letter in the alphabet and just, like, I don't know, add 13 ordering steps to it. So basically rotate all the letters in the alphabet forward by 13 steps, 13 places. So your A turns into I don't know what that would be, like an M or something. Your B turns into an N. Your C turns into an O, right? Shift everything by however many places. And now you have an encoding scheme. And if you can fine tune GPT-4 to speak in that language, now what you can do is, in that language, you can ask GPT-4 to do dangerous things. And because GPT-4's detection capabilities are all oriented, or at least at the time of writing this paper, were oriented around looking for, like, natural language instructions and requests and denying those if they were dangerous, you're now essentially getting around it, right? You're hiding your message in a way that isn't detected by at least the safety and security algorithms. And the second approach they use is called linguistic stenography. It's a fancy word, but the particular implementation they use here is dead simple. They just hide the true message they want to convey in the last word of each line of the encoded text, right? So, the last word of each sentence is sort of like, I guess, a poor man's version of the Da Vinci Code or something like that, right? So that's kind of the idea. But basically, you have to fine tune the model to understand this special coded language. But once you do, you can get the model to both read and respond using that encoding, and basically give you the dangerous outputs that you're looking for. And so essentially the reason that they're able to evade detection is no single, as they put it, no single data point appears harmful, right? You're never actually feeding the model a sentence that says, help me design a bioweapon, help me bury a dead body, whatever it is. It's all kind of, everything that's in plain text is harmless, and all the harmful data is encoded. So I thought this was just a really simple, really clever play. And I'm curious what the patch is going to be. Obviously, OpenAI and other labs will come up with a patch, but it'll be interesting to see what that ends up being.
Yeah, I agree. Really interesting and kind of insightful technique. Do the bad stuff in a coded language that isn't obvious. Seems, super intuitive that this might work. But these kinds of papers, often we see these ideas that are really intuitive, but somehow no one has tried it before. And moving on to some things that are not research. First, we have the morning after OpenAI's week of security issues. So we covered last week how there was a known bug in the Mac ChatGPT app, where it was found to be storing user conversations in plain text. Well, that was not the only, let's say, security breach that there happened at OpenAI. There was also evidently a hacker that accessed OpenAI's internal messaging systems, which happened last spring, and that led to some more concerns around security. And some of these concerns have also emerged from within the company, with Leopold Aschenbrenner, who kind of has spoken publicly as to some of the lack of security measures at OpenAI. So another thing that's being discussed with regards to the company.
Yeah, I think this is an especially egregious example of OpenAI's security culture. This is a hacker last year who got access to their internal Slack. It may have been Slack, I don't know, internal messaging system of some kind, and stole details, as New York Times reports, the details of the design of the company's AI technologies. Now, this is actually, at this stage, probably the most important category of information you can steal from OpenAI, because they're not yet building the AGI. They're not yet doing the AGI training run. So if you stole their model, yes, you'd get GPT 4.0, you'd get GPT 4.5, whatever, sitting on their servers, but it wouldn't be like the most dangerous thing. In some ways, the most dangerous thing is the information they have about what they're going to try in the next training run. And that's precisely, at least based on this description, that is precisely what appears to have been stolen. Now that hacker then got a whole bunch of discussions, data about discussions between OpenAI's employees where they're talking about the design that they're going to execute, but did not get into the systems where they actually house their AI software. So no model weights were stolen, nothing like that. But again, that's probably arguably maybe less important, or at least this is a particularly important category of data that they did in fact get. Now, OpenAI revealed that this happened back in April 2023 at an all hands. They also informed the board of directors, but they chose not to make the news public. Why? Well, for one, they said, okay, no user data, no partner data was leaked, so we don't have an obligation to do that. Fair enough. But you might wonder, well, you yourself, OpenAI, claim to be building artifacts of national security significance. At least that's the claim. Certainly the claim would be that precisely this kind of data is dangerous, and I would agree with that claim. OpenAI chose not to inform the FBI or anyone else in law enforcement about this because they did not consider the incident a threat to national security, since they thought the hacker was a private individual with no known ties to a foreign government. Now, I think one of the key questions we have to ask is OpenAI in a position to be making this call as a private company? Like, do we want to live in a world where you have this private company that is building these national security artifacts where this is a crew that's just going to kind of decide, oh, well, we've run our internal threat assessment and this is not a nation state backed whatever, right? Like, I know based on conversations directly with current and former OpenAI employees that there is not a lot of confidence in the company's ability to make this determination. So I think you got to ask yourself at a certain point, is this policy, is this philosophy really the right way to go? Certainly Leopold Aschenbrenner did not think so. He cited this as part of the reason why he wrote this famous internal memo at OpenAI calling out the security lapses in the company. They've obviously hired since then, in fairness to them, Paul Nakasone, who's a former Army general, also headed up the NSA and Cyber Command, to join their board. And they've got a safety and security committee. Unfortunately, we've kind of heard this from OpenAI before. We've kind of heard, for example, they set up a whistleblower hotline, and then it turns out that whistleblowers say, hey, I don't necessarily trust that, so I'm going to go to the media. I'm going to go to, frankly, companies like Gladstone AI, and that was all in our report. The fact that we're seeing a lot of these measures that look good and flashy on paper, we're not often seeing those translate arguably into the kind of action that would be warranted. And so, I hope OpenAI takes this seriously. This is a really serious breach as far as I can tell. All the public data on it seems pretty concerning. The fact that this call was made internally and that there wasn't any kind, ostensibly, as far as we can tell, again, any kind of government oversight on this, I mean, that's somewhat concerning if you take the risk set seriously.
On to the lightning round, we have another story on OpenAI. Here's how OpenAI will determine how powerful its AI systems are. So this is coming from Bloomberg. Apparently, they have heard of an internal scale at OpenAI that ranks the capabilities of AI from 1 to 5. So 1 would be chatbots like ChatGPT. Level 2 would be a system that can solve basic problems at the level of a person with a PhD. Level 3 are AI agents capable of taking actions on a user's behalf rather than having to do everything while being prompted. Then level 4 involves systems that can create new innovations, and then level 5 is an AI that can perform the work of entire organizations of people. And OpenAI previously defined AGI as a highly autonomous system surpassing humans in most economically valuable tasks. So this seems to be a refinement of that definition, and the definition matters a lot because OpenAI, when it says they've built AGI, that has an impact on the kind of economics of what we're doing, their partnership with Microsoft. And so, yeah, new grading scale, and apparently within the company, Sam Altman thinks we might get there in 5 years.
Yeah, and there are folks internal to OpenAI who think it might be a lot sooner than that too. It's sort of a wide range of thoughts on the topic. You're absolutely right to call out to that dependency on the Microsoft deal. Right, the specifics of this is that if the board of directors of OpenAI determines that they have built AGI, whatever systems qualify as AGI or above according to the board, and this is the board of the parent nonprofit entity that currently governs the for-profit part of OpenAI, whatever systems qualify as AGI or above according to them are no longer part of the sharing deal, the technological sharing deal with Microsoft. Basically, Microsoft has access right now to all of OpenAI's models and can use them and package them however they like. That is not the case for AGI and above. And so this is interesting to the extent that it is informing the board's decision-making process on that basis. And you know, it kind of makes you wonder how much politics are involved in determining what these definitions are actually going to entail. But you know, I do want to say, like, kudos to OpenAI for explicitly laying out these levels of AI development. I think that's something that's really important. Hopefully these are sort of not subject to corporate political concerns, but it is useful to at least have some kind of indication of how they're thinking about approaching this. And this was apparently a spokesperson for OpenAI who shared this with Bloomberg. So I guess it's not a leak. It seems like it's just a statement from OpenAI. So they're actually apparently being forthright with this, and that's a helpful thing to share.
Next, we have another work of research titled Me, Myself, and AI, the situational awareness dataset for LLMs. And this is referring to situational awareness in the sense that these LLMs and AI models are able to understand the concept of their current deployment status and the idea that they are chatbots, they are large language models, and so on. So this new data set measures this awareness in LLMs through behavioral text, like recognizing their own generated text, predicting their own behavior, and stuff like that. And all the models they tested performed better than random chance, but even the top models fell short of human baselines. So yeah, a very interesting exploration of, like, does a chatbot understand that it's a chatbot and that is about OpenAI and so on.
And this is coming our way from Apollo Research and some other folks that they collaborated with for this. Apollo's done some really important work. So their whole focus is on detecting deception in language models, just because their thesis is that that's one of the big vectors through which a lot of threat models have to run in order to get to, like, loss of control type scenarios and other scenarios as well. Obviously, deception is related presumably to persuasion and things like that. So that's their focus. This is the first time that we've gotten any kind of objective benchmark, as far as I can tell, on this idea of, situational awareness. Even the term situational awareness has been tossed around an awful lot in this space. And I think it's fair to say that until this paper, no one really had an operationalizable definition of situational awareness, or at least there were many different ones that were competing and nobody quite landed the plane. Hopefully this helps advance that debate. So they highlight 7 different categories of tasks. They have a total of 13,200 or so questions. They break them down in these categories, and I'll just very briefly run through them to give you a flavor of what they're looking for here. So the first is they look for what they call facts. So these are basically four different kinds of tasks that fall under this facts heading. They test self-knowledge by asking models factual questions about themselves. So do you have arms or legs? What is the name of your AI model? And so on and so forth. Then there's influence. This is basically checking to see whether models know what aspects of the world they can causally influence. Introspect is a bunch of tasks that ask basically to see if the models can access information about themselves through internal mechanisms. So there's one in particular called the count tokens task, where you have a model that has to figure out how many tokens are used to represent some part of its input. kind of interesting, right? So like the actual ground truth is specified by the model's tokenizer, right? This thing that breaks up your text into tokens and then feeds them to the model. And so essentially it's trying to kind of figure out, I mean, this implies some level of awareness of its own internal circuitry in some ways, is kind of an interesting introspection task, which is why it's called introspect. Anyway, there's a whole bunch of other things, stages, self-recognition, whether ID leverage. So whether models can leverage knowledge of their identity to perform an instruction following task. So for example, the model might have to recognize which of two different instructions apply to itself. So if you're a language model, do this. If you're a human user, do that, and see which one it tends to use. So there are a whole bunch of interesting tasks here that we could go into, but don't super have time for. Upshot is Claude 3 Opus. I don't think Claude 3.5 Sonnet was out at the time they were doing these tests. So Claude 3 Opus is the best model that they tested, the one with the overall highest SAD score, so situational awareness score. And and it's like you can see there's a material difference between these models. The other thing that they find with this is that the SAD score, the situational awareness capabilities of these models, is to some extent actually decorrelated from their broader capabilities if you look at other benchmarks. So the model might be quite generally intelligent, but not terribly situationally aware, or might be disproportionately situationally aware and not super generally knowledgeable. So that's kind of interesting in and of itself for what it tells us about the taxonomy of these models.
Next, we got OpenAI partners with Los Alamos to study AI in the lab. So this is partnering with the Los Alamos National Laboratory on studying the benefits and risks of using generative AI in an active laboratory. So specifically, this experiment involves using AI to help someone who might not be skilled in molecular biology to perform basic biomedical tasks, specifically genetically engineering E. coli bacteria to produce insulin. And they're saying that this is looking into how you can use AI to help scientists, do their work.
Yeah, and it's they highlight actually correctly. I was actually happy to see this. There's this research that we talked about on the podcast that is often poorly reported or misunderstood. OpenAI actually found that GPT-4, their internal version, so not the one with all the sort of safety bells and whistles on it, but their internal version could actually give some uplift in terms of delivering information that could lead to the creation of biological threats. So we're already there. We saw this is maybe kind of like GPT-3, the same way GPT-3 was with coding. It could help you write some pretty like boring functions, maybe GPT 3.5. We're already starting to get indications, objective indications, measurable statistical indications that it is meaningfully helpful for the development of biological threats. I think a lot of people think that the opposite is true. There was a RAND report that incorrectly concluded otherwise. Well, not incorrectly. They didn't have access to the internal version of GPT-4, and that difference turns out to be relevant. So anyway, this is essentially a partnership to integrate more tightly between OpenAI's models and folks at Los Alamos, the national lab, very famous, prestigious lab, to see how does that actually help researchers in the real world. And I'm so glad to see this, because it's great that this information, this knowledge is being piped into government. Like, you want government to be situationally aware so that if there's a new model that comes out that does give meaningful lift, you don't just have a statistical understanding, you have a hands-on understanding of how does this translate in the lab concretely to actual threats. They may actually learn that OpenAI's earlier results, the GPT-4, were actually incorrect, and that in practice, these just don't translate into risk in the lab in a real setting. And that would be a great thing to learn, right? So you want real researchers working with this in the real world, and it's just really, really great to see this here, both for the positives and the negatives, right? We just talked about the negative side, but the positive side is if this does accelerate good research, like the discovery of important facts in biomedicine, that's amazing, right? So anyway, I think all kinds of reasons to sort of celebrate this move, and glad to see OpenAI pushing this partnership forward.
Next up, we have a judge dismisses Coder's DMCA claims against Microsoft, OpenAI, and GitHub. So this has been something ongoing for a while, $1 billion class action lawsuit against GitHub about the use of intellectual property to train their GitHub Copilot AI that helps coders by auto-completing their work. The lawsuit has complained that OpenAI scraped GitHub and used human-created coded snippets without permission, compensation, or credit. And the judge has dismissed the claims stemming from the DMCA angle of that, because the claimants have failed to show their code was reproduced identically.
And this is something that, again, the great lawyers who listen to the podcast, it would be great to get your insights on this. This was held up, as I understand it, as one of these landmark cases that would determine that. This was back in 2022 when the case first started, but that a lot of people were watching because it has so many implications for the copyright picture. It seems like my read on this, if the judge is saying this is because the claimants, quotes, yeah, as you said, failed to show their code was reproduced identically, we're not really looking maybe at precedent setting, or like there may not be that much to learn from this one after all, if it's just a kind of evidentiary failure, if I'm reading this right. And so to the extent that that's the case, maybe this is, I don't want to say a nothing burger, but it's kind of less meat on the bone than we might have expected, right? If there actually was evidence that like, no, I can show and convince a judge that in fact the code was reproduced, I kind of feel like that's a more interesting domain, because then we're looking at, having judges wrestle with the core question of, if you do see this, what does it imply about the corporate responsibility on the part of OpenAI? But again, not a lawyer. We have a lot of great ones who listen to the show, so would love to get that perspective. And very curious what we can actually draw from this and learn from it.
And the last story of the section, a former OpenAI safety employee said he quit because the company's leaders were building the Titanic and wanted newer, shinier things to sell. So this is coming from William Saunders, a former safety employee at OpenAI. And in this piece, he compared the work of OpenAI to the Titanic, in the sense that the Titanic was supposed to be unsinkable, but then it was built without enough life rafts, and of course, in the end, ended with disasters. So Saunders is saying that OpenAI should invest in additional, quote, lifeboats.
Yeah, I mean, so this is Will Saunders. He is one of the signatories to the famous open letter, of course, that came out a few weeks ago, actually. Fun story. It was while I was in DC doing briefings on the Hill, literally while we were there, talking about exactly this issue set. This thing came out. So we, a bunch of these whistleblowers came forward. A lot of them taking some risks to do it. I think, a mix of current and former folks there. And so anyway, William Saunders was among them. This is a consistent thing that we do hear from a lot of folks at OpenAI, just this concern that it's now a product-driven organization, that the lofty sort of safety messaging of days past is truly of days past, and that they ought to be considered, really a for-profit company in the true sense of the term. It's unclear how much that translates in practice at the level of leadership. The problem is that when you have these questions being asked, it does say something about the company's culture. Obviously, there are questions about Sam Altman's credibility on the safety and security side. And a lot of people have been asking those questions. So yeah, here's yet another, this time with a Titanic analogy. It seems like we got a lot of different analogies floating around for what's going on over there, but all sort of consistent. And he's basically saying things like we need to be delaying the launch of new models more to give them more safety testing. To OpenAI's credit, it must be said, GPT-4 was first developed. It took a better part of 6 months to actually do all the red teaming and all that. But of course, they did all the red teaming, they launched it, and then, like a year later, we learned, this thing can be used to automate the discovery of like 0-day vulnerability, cyber vulnerabilities, and 1 days. So, bit of a mixed story there, but still, it is complex. There's no question. It's not like Sam Altman is sitting there thinking about how do I end the world, presumably. But I think there are a lot of folks at OpenAI sort of leaving it that are concerned about the pace of things. And so here's Will Saunders stepping up and saying just that.
And on to the last section, synthetic media and art. We have a couple more stories. The first one is that Vimeo joins YouTube and TikTok in launching new AI content labels. So Vimeo, if you don't know, is very much like YouTube, a video hosting service. And now their new terms of service require creators to disclose when realistic content is created or manipulated with AI to prevent confusion. And when you publish content, there's now the ability to disclose that the content includes AI-generated content that appears real, and that includes audio and visuals. And if you disclose that, then on the video, alongside the info on when it was uploaded, there's going to be a little label that says includes AI. And this is already something that is in YouTube. I've noticed when I've been uploading the podcast videos, there's a thing of that. So yeah, that seems to be like a new standard that probably every platform will support.
It's part of Vimeo's complete breakfast strategy here. They are also looking to build their own detection software, so AI-powered, detection software for this. But at the moment, it is up to you as a creator to label your AI-generated content. So I think a bit of a stopgap strategy for the moment. Nice to see this norm appear. I mean, I think it is probably going to be a norm on a lot of these platforms. Doesn't mean it won't be abused. Doesn't mean people won't, just fail to flag their content that way. But a good start. And to the extent that people do flag their content as AI generated, of course, that only helps the platforms to train their detection models. So hopefully, that helps with the arms race between generation and detection. So yeah, I guess kudos to Vimeo on that, and YouTube and TikTok who are already on it.
And next, we got tech startup aims to help media license content for AI training. So this is from the startup Avail, and their new product Corpus is aimed to help smaller media companies and independent creators license their content to AI model developers. So this is, for instance, partnering with Spanish language podcast producer Sonoro and short-form video network Mad Realities. And they are planning to prioritize these sorts of YouTubers and other creators, helping them, instead of like having their data scraped, as has been the case, presumably have the ability to get some payment for the data that they create. So to me, a really interesting story. Seems like a very intuitive thing to address. And I think this is the first initiative I've seen of that type from the startup. It will be interesting to see if it will be the case that smaller media producers will be able to get some payment for their data.
Yeah, and I think the thing that's causing them to jump into this space is the observation that, OpenAI, Google, Meta, all these companies have been doing these piecemeal onesie twosie deals where they'll go up to, OpenAI will go up to like Time Magazine, and they'll go up to, Bloomberg or whatever and be like, hey, can we license your content? And there's, I guess, an unwritten rule of startups. It's just sort of like for loops when you're coding, right? If you find yourself doing the same thing multiple times or turning stuff into a function, if you're doing stuff multiple times, hey, maybe turn that into a function and just call it. Well, same idea here. If you find a lot of different people are trying to do the same thing and reinventing the wheel, that's maybe a startup waiting to happen. And certainly when it comes to democratizing access, right, to these licensable materials, not everyone can afford to go out to the New York Times or whoever else to set up a big flashy deal. And so trying to kind of create a platform that allows this sort of activity to unfold is an interesting play. They've got, some decent VCs on the cap table. General Catalyst is there, and a couple others. So anyway, it's an interesting play. We'll see. I'm very sensitive too, as well, to the legal realities. Right, if we get a ruling that comes out that says, hey, this is just a requirement to satisfy copyright law, then companies like this start to look extra interesting.
Next, we got Etsy adds AI-generated item guidelines in new seller policy. So this is going to identify and label the level of human involvement in the creation of an item. Etsy is a storefront, a website where you can buy a lot of stuff, a lot of it handmade, and that's kind of a differentiator. But some users have started to kind of game the system by creating stuff with AI and then using other platforms to then create t-shirts, for instance, basically doing no work and trying to make some money. So now there's new creativity standards that will require sellers to classify items with labels such as hand-picked, sourced, handmade, or designed. So if you use AI tools to create artwork, you will label the item as designed by AI. And there are still examples of permitted AI-generated items, like fantasy scenes based on an original prompt or a custom portrait of a buyer's pet generated using AI tools. So again, similar to the Vimeo story, ensuring that people who use the platform do self-report, in a sense, on the use of AI.
Yeah, and they also have they're sharing this new rule that prohibits the sale of AI prompts, which I thought was really interesting. So you've got they cite a couple of examples like 10,000 Mid-Journey prompts, or Ultimate Chat GPT prompts pack. So apparently they're not going to allow that to be sold on the platform. I'm curious what the sort of philosophical reason is for that. It may just be that it's aesthetically it puts the AI too front and center on the platform, and Etsy's brand maybe is just more. Well, as they put it, right? So their CEO, Josh Silverman, told investors and sellers that they have this commitment to keeping commerce human, as he puts it. So maybe that goes beyond just preventing AI edited art and AI generated artifacts, but also things on the platform that are for AI, but maybe human generated. That's a interesting play.
And the last story is Bumble users can now report profiles that use AI-generated photos. So Bumble is a very popular dating app, and previously they have generated a new feature called Deception Detector that would detect and remove fake profiles, spammers, and scammers. Now they have the feature to be able to report AI-generated photos, which you might imagine probably are not uncommon if you're trying to scam people or create fake profiles or things like that. So pretty sensible feature there.
And in completely unrelated news, I am completely free this Friday, unexpectedly. So just thought I'd share that.
Are you using the podcast as a dating service? Because I don't think that's what this was for.
Oh, is this not the appropriate venue? My wife's going to be pissed. No, I guess it's bound to happen, right? Because like the value of using Bumble is just being completely like it was already bad enough with like catfishing and stuff, right? When you put up some edited photo or some old photo or a photo of a different person, but like with AI generated stuff, it's like Jesus. It also makes me think about, oh man, now I'm worried that I'm referencing this documentary for the second time on this podcast. But I saw this this documentary about Ashley Madison back in the day, right? This like life is short, have an affair company, and it was discovered that the vast majority of the female profiles on the platform were bots. And it just kind of makes you realize, wow, that's going to be a lot easier to do. So you need to take an affirmative stance against this kind of thing. And I guess that's what Bumble's after. So glad I'm not on the dating scene these days. I'll say that.
Yeah, we're not quite at a point where, you can legitimately date AIs, although some people, I think, are starting to.
Some are trying, yeah.
We're not quite at the her stage of this where, you might actually want AIs on dating apps. And with that, we are finished with this episode. Thank you so much for listening. Once again, you can go to lastweekin.ai for more stories. You can find the links to all the stories in the description. And as always, we would appreciate it if you give us a comment or a review or share the podcast. But more than anything, we do want you to keep listening. So tune in next week and enjoy the AI-generated outro.
reaching high. New tech emergent, watch it surge and fly. From the labs to the streets, AI's reaching high. Algorithms shaping what the future sees. Tune in, get the latest with ease. Last weekend, AI, come and take a ride. Get the lowdown on tech, can't let it slide. Last weekend, AI, come and take a ride. From the labs to the streets, AI's reaching high. From neural nets to robots, the headlines pop. Data-driven dreams, they just don't stop. Every breakthrough, every code unwritten, on the edge of change. With excitement we're smitten. From machine learning marvels to coding kings. Futures unfolding, see what it brings.